Okay, after reflection, I have to do dilation, okay, which is the second step in transformation. Okay, I do an example here to show you what it is. If I transform the standard graph y equals to x squared to y equals to 10 times x squared, and there is a dilation. In order to describe it, I write there is a dilation, okay, by a scale factor of 10 along y-axis. Okay. The important part of describing a transformation is you always have to mention the scale factor of something. Okay, always use the word scale factor. In the exam, if they ask you to describe dilation of a function and you didn't write the word scale factor, they take mark off you. Okay, this is very important. And well, the scale factor you can just copy it from here. Okay, just copy it from here and make sure it's along y-axis. Okay, this is a bit tricky. You can write down dilation by a scale factor of 10 along y-axis or in y-axis or parallel to y-axis. Also, you can write it as from x-axis. Okay, these four are the same thing. These are the four most common ways of describing dilation. Okay, they means the same thing. They means the same thing. Okay, the trick is you have in along parallel to y-axis, but from x-axis. This actually oh, this is actually happened in year 12 final exam. What's happened is in a multiple choice question, the examiner asks you to the examiner describe the dilation by word using from x-axis and ask you to write down the new equation of the function, and a lot of students get confused with that, and they get a wrong answer. So it's very important to know in along parallel to y-axis is the same as from x-axis. Okay. Now I write another dilation. Okay. If I if okay, I have to transform dilate the graph from y equals to, okay, say this one sine x, okay, to y equals to sine 2x. Okay, what I did here is, well, okay, what I did here is just say fx, okay, equals to sine x, and I transformed it to f2x, which is sine 2x. Okay, so what I did is I substitute 2x in the position where originally should be x. So the dilation, there is still dilation, but the dilation is different. Okay, and the correct way to describe this dilation is okay, okay, it's like this: dilation or dilated by a scale factor of okay 1 on 2 half in x exit along x axis or parallel to x axis or from y axis. Okay, and those those are the same. Okay, they means the same thing. They, they all means this thing. Okay, the trick in this part is you have to use the scale factor is basically 1 divided by the number that you times x. So in other words, what's happening is when you have a dilation in y-axis, well, just copy the number in front of the whole equation, in this case 10 down. But when you have a dilation, well, we'll have when you have a number times x in the bracket, well, I can put a bracket down there. Okay, when you when you have a function, well, which is a factor, scale factor in the bracket here, the scale factor changed to 1 divided by whatever the number next to x. Okay, whatever the number that had timed x, and in the direction which is in x-axis, along x-axis, or parallel to x-axis or from y-axis. Okay, this is actually you have to remember this thing in for your transformation. Okay, so it becomes 1 divided by not the uh, not the original way. Okay, not the way there. I do some more examples to show you. Okay, in the next page. Okay, for instance, if I ask you to describe a dilation from y equals to sine x to transformation to y equals to 10 sine let's say pi x. Okay, the general formula is say f gx equals to fx, and transform fx to jx, and the function jx is equals to a function bracket in bx. Okay, the idea, the formula is there, and a is your scale factor of a along x along x axis. Okay, where your scale factor of 1 on B along y-axis. Okay, and just remember when you use uh, well, what I can recommend is when you describe a function, try not to use the word from. Always use in, along, or parallel. If you use from, sometimes it's just confusing. But what happens in the exam, if they ask, you have to know what does front mean. From means. Okay, you only have to know them. But when you describe a dilation, never use it. Never use the word from. Always use in, along, parallel. Okay. The general formula is there. Okay, you can put it in your notes. Okay, let's do an example here. Okay, I have y equals 10 sine pi x. Pi is just a number. Okay, 3.1415. So, to describe, and I notice there are two numbers there, 10 and pi. So there is going to be two dilation. Okay, so I write down the first one. The sequence really doesn't matter. Okay, dilation by a scale factor of say 10 along, use the formula here, along y axis. Oh yeah, sorry, I okay, sorry about that. I write down the wrong formula. Okay, sorry, it's scale factor of a along y-axis. Yes, I was right. Did I? Okay. Y-axis and the scale factor of 1 on B along x-axis. Okay. Just remember you have always 1. The scale factor used is 1 divided by the number that next to x. Okay, or in the bracket next to x. Okay. Now, okay, we have something like this, and the other dilation in this function is dilation by a scale factor of 1 on pi along x-axis. Okay. In order to sketch this graph, so okay, and we can use this information to sketch the graph from a standard graph. The standard graph looks like this. This is basically the standard graph. Okay, from 0 to 2 pi, and the maximum is 1. Okay, the minimum here is -1, which is x and y. Okay. Now, in a new graph, okay, what I can say, okay, because there's a dilation by a scale factor of 10 along y-axis, so the value in y-axis should be 10 times more. So my maximum value becomes to 10, and my minimum value becomes to -10. Okay, so in other words, the amplitude of the sine wave changed. Okay, and we call this the amplitude.